Hello everyone. This is week 15 Fourier analysis. So before we start with week 15, we just go and revise what we learned previously. We first learned the Laplace transform. Okay. Then we studied inverse Laplace transform. Okay. Inverse of Laplace transform, and then we study application of Laplace transform. Okay. Now this was actually chapter 13. Okay, and then this was chapter 14 of your textbook. Now this is our chapter number 15 of your textbook, that is named as Fourier analysis. Okay, so before going into Fourier analysis and how we can find what does Fourier analysis mean, what is Fourier series. Okay, before that we just going to define these three function again. I know you know that what is this periodic function, what is even function, what is odd function. We'll just do a little bit revision, and then we'll straight step to what the Fourier series. Okay, so what is a periodic function? So we have learned that periodic function is nothing but a function which can be written in this form. Okay, a function which repeat itself after certain interval of time. Okay, and what is that interval called? The time period of that particular function. Okay, so any function of this form is called periodic function, and this T naught, this capital T, this is actually the period of that particular function. Okay, for example, sine. So let's say this is our function. Okay, it start here, it end here, and then again start over here. So we say that its period is how much? 2 pi, right? Okay, say we have another function, say we have a square wave of this form. Start somewhere, then end, then again start somewhere, and then end. Okay, so from this point to this point, this is its period t. Okay, so a function which repeats itself after equal interval of time is called what? Periodic function. Okay, so I hope so you understand. We don't need to go beyond this definition. Okay, you just need to remember that periodic function is a function which repeats itself after equal interval of time, and that interval of time is called time period. Okay, so it will repeat after this time period. It will repeat itself after this time period. Okay. Okay, now what is even function? So say you are given a function, say f of t, and you need to find out whether it is even function or odd function. So what you do is you put t equal to minus t. Okay, instead of t you put minus t over here. Okay, so this is minus t. Okay, so if this again equal to f of t, okay, means to say this is plus, and it does not change f of t, then this function is called what? Even function. For example, you are given a function, say f of x equal to x square. So it's an even function or odd function. We'll state some value, say x equal to 1. So this gives you 1. Okay, if you put say here minus 1, this will again give you 1. Okay, so this is equal to f of 1. Okay, and this is what? F of minus 1. So f of 1 is equal to f of minus 1, right? So this is what? Even function. You can straight away say that this is even function. right? I know you know this thing, just I just want to remind this a few things because we're going to use them. This is very important for us to use in Fourier analysis. Actually help us a lot. If we know the function that is even or odd, it's going to help us in Fourier analysis. Okay, so just remember what is even function and what is odd function. So you are given a function, odd function. Okay, odd function. So a function of this form, f of t is equal to f of minus t. Okay, no, sorry. If you take, say, for example, you have a function, say, x is equal to x cube. Okay, and you put here x equal to 1 and then x equal to minus 1. Then what's going to happen to this? F of 1 will be 1, but f of minus 1 will be minus 1. So this is equal to what? F of x, right? So f of 1, so this is minus f of 1, right? So any function of this form is what? Odd function. You can write its generalized equation as f of minus t is equal to minus f of t. This is your function and we call it odd function. Okay, so you just need to remember these two things. There is another function, half wave symmetry, but we'll deal with it later. Okay, so far we understand what is a periodic function, what is even function, and what is odd function. Okay, so now we can switch toward this Fourier analysis. So this Joseph Fourier find out that any periodic function can be written as the summation infinite sum of sine wave which are integer multiple of the fundamental, that is the frequency which correspond to the period of the repetition. Okay, so this is the basic definition, that if you are given any periodic function, you can write it in term of sine, but it will be summation of sine, okay, from 1 till infinity. Okay, you already know that you already work with the oscilloscope and function generator. You might know that in function generator you have this kind of signals. You have a square wave signal. Okay, you have this kind of signal. Yes, this seesaw type signal, and many more of such kind of signals, right? What if I told you that you have just a sine wave, and using this sine wave you can produce these signals, this one, and from this you can produce this signal. Obviously reverse is also true. Okay, so that would be really interesting. That's how you can make your own functional generator. You can produce a square wave, you can produce a seesaw wave, and so on. Okay, so that will be quite interesting. So this Joseph Fourier, sorry, this man introduced the concept of Fourier series, that if you have this kind of wave, which is what? Periodic. This is the first and most important property must your signal have in order to apply this Fourier series. Okay, so this man said that if you are given any periodic signal, you can write it by infinite summation of sine wave. Okay, means to say, if you are given just a sine wave, you can produce this signal. If you are given a sine wave, you can produce this signal. Okay, so the necessary definition must satisfy the function must be what? Periodic. Okay, so I think so we can start with the formula, that is the Fourier series analysis now. Okay, so you understand the motivation behind that. You are given any signal, you can write it an infinite sum of that uh, waveform. Okay, So the formula we can use is say we are dealing with say voltages. Okay, so you are given any voltage. Okay, and and that waveform is say periodic, so you can write it this way. This is your formula. This will be a naught n equal to 1 till infinity. This will be a n cos of n omega t plus bn sine of n omega t. Okay, you just need to remember this formula. Okay, you just need to remember this formula. Okay, so you are given any function. Okay, you can any function given, say f of t. Okay, and you need to write that equation, that waveform by infinite summation of sine wave. Okay, in a minute we will let you know how it can be done. Okay, we'll take a simple example and then we'll produce that signal by summation of these sine wave and cosine wave. Okay, okay, so here we have this a naught. These are constant. Okay, this is a n and this is say bn. The a n and bn value will change with value of n. Okay, this n is starting from 1 till infinity. Okay, so this could be 1 2 3 4 5 6 and so on. Okay, till infinity. So this is the formula you need to memorize. Okay, now what is a naught? These are the constant. Okay, and we call it them Fourier coefficients. Okay, we can write it here. Say this is a these are Fourier coefficients. Okay, this is naught, a n and bn. Okay, so how you can find out the values of these? You will just need, this is a naught is say you are given a function f of t. You just need to find its average value over interval plus t. Okay, and 1 by t. Okay, you just need to find your function average value and you will get a naught. What about a n? You can find this value by 2 by t. And t start from the limits stay the same. Okay, this is t plus t, and this will be f of t cos n omega t dt. Okay, and bn will be I'll write bn here. This will be 2 by t integral t from t to t plus capital T f of t sine n omega t dt. So this is a complete Fourier series. Okay, this is your Fourier series. These coefficients you can find this way. Okay, n naught should be just the average value. A n will be equal to 2 by t integral f of t cos n omega naught n dt, and b n will be this thing. Okay. And this is how you find. You just need to find out a naught, a n, and b n. You put it over here. You get your desired results. Okay. This a naught is nothing but just a DC value. Okay. So I told you that you can build your function generator by yourself. For example, if a function generator doesn't have a particular waveform and you need that for your circuit, that this is Fourier analysis will rescue you over here. Okay. So this is the basic formula, and you need to memorize them. Okay, and here I'll tell you, before I told you what is even function and what is odd function. So if you know that your function is, say this is an even function. Okay, so for even function you will have only the a n values. Okay, a n will be non-zero, b n will be equal to 0, or a naught will be equal to 0. Okay, So if you know that your function is f of t is even function, then you don't need to find out this an sorry, this a naught and this bn, okay, because that will be automatically equal to 0. We will see that in example, okay. But here just for you need to remember these things, okay. This is for even function, okay. And the same way we can write the same for odd function, that if you have given f of t is, say this is odd function, okay. Say f of t is given an odd function, then uh, you will only have the bn values. Bn will be non-zero, that is bn will exist, okay. And all a will be equal to 0, okay, and a naught will be equal to 0. This will be equal to 0, okay. So a n equal to 0 and a naught equal to 0, right. So you just need to remember these two things, that if your function is even, then a n is not equal to 0, and not equal to 0, bn equal to 0, and for odd function bn is not equal to 0, that is its value exists, an will be 0 and a0 will be 0, okay. We'll see this in a minute in example when we solve example, okay. So say this is our page 1, so you just need to remember this formula, okay. And this is how you find these coefficient. You put this coefficient over here, your desired f of t will convert it into summation, infinite sum of sine and cosine value, okay. So I think so we can now move on to simple example, okay. So let's say we take an example uh, of this form. You are given, say, a waveform. Say this is your waveform, uh, say 1 2 3 4 5, okay. So you are given here 5, 1 2, so say this goes till say 1 is here, okay. This goes to -1, again this goes to 5, then to -1, and then and so on, and this is a periodic function like this, okay. And your period is from here to here, this is t, okay. So from here to here, this is t by 2, okay. Its value here is 5, its value here is -1, okay. You are giving just this waveform, and what we need to do is we need to find the Fourier series for this, okay. So what we mean by Fourier series, we need to find the infinite sine functions which can be combined together to form this signal, okay. So what we need to do, I told you, just you need to remember this formula, okay. So in this formula we just apply these equations, okay. You just need to play with this equation, okay. First you need to find a naught, first you need to find an, then bn, put these values over here. You will get your desired result, okay. And I'll show you how these sine and cosine wave will combine together to form your desired signal, okay. So we need to find first value a naught. So what will be a naught? Huh? You will need to find the average value of your function, right? So your function will start from t to t plus t, okay, f of t dt. But look closely to your waveform. Its value is 5 from 0 to t by 2, and its value is -1 from t by 2 to t, okay. So we can split this way, that 1 by t from 0 to t by 2, f of t is what? 5 dt, right? And plus uh, t by 2 to t, our value is how much? -1. So this will be -1 times dt, okay. Just solve this integral and you will get your a naught, okay. So you know how to solve this integral. Okay, so this is your a naught. Okay, so a naught will be 1 by t times 5t, and limits are 0 to t by 2, plus uh, sorry, minus t. Okay, this is minus t, limits from t by 2 to t. Okay, and you just apply these limits, and say this is page 2. You apply those limits and you will get your desired result, a naught equal to 1 by t, uh, 5t by 2 minus 0. Okay, and plus minus t minus into minus plus t by 2. Okay, we put those limits in. You will get in next step 1 by t, and here you get just 5t by 2. Okay, and minus t by 2 over here, right? And you further solve it. So 5t by 2 minus t by uh, 2, you will get how much? 1 by t into 4t by 2. T and t cancel, you get 4 by 2 is 2. So we got our first DC value, that is 2. This is your DC value. Okay, this is a naught. Now what we need to find out, well, the second part is what will be an. What will be an? You need to find out. So you already write the formula, that your formula will be 2 by t integral t to t plus t, right? This is plus. Okay, f of t cos of n omega t dt, right? So this is your formula, and we will evaluate this thing to find out an. Okay, so it's really easy. You just need to find some integral and you will get your desired result. Okay, then you put different values up, and over here you will get a1, a2, a3, a4, a5, and so on. Okay, so this is simple. Now you know that our function was our original function was defined from 0 to t by 2, its value was 5, and from t by 2 to t, its value is minus 1. So you just need to remember this thing. Okay, we are taking this function. Okay, so for an, we can also write an equal to 1 by t integral. So from 0 to t by 2, our f of t was 5 cos omega nt or n omega t. Okay, and plus from t by 2 till t, our function was minus 1. Okay, then sine n omega t, and then dt. Okay, you will write dt over here as well. Okay, sorry. So this is your an. Okay, this is how you find value of an. Okay, actually your function is this one. For an, your function should be this one. So this f of t is we can write from this waveform that your f of t is defined as f of t equal to 5 for t greater than 0 and less than t by 2, right? And this is equal to minus 1 for t greater than t by 2 and less than t. Is it clear? So I'm just evaluating this f of t and then these intervals. Okay, so that's how I write them. That from 0 to t by 2, this is 5 cos omega nt dt, and from t by 2 to t, this is minus 1 sine n omega t dt. Okay. Now you need to solve this integral. So I hope so you can solve these integral, but in this example I'll solve, and another example you will do yourself. Okay. And this is 2 by t. Okay. Now 2 by t stay over here. Okay. And this is from 0 to t by 2. You take the integral of this thing, so this will give you 5 sine n omega t. Okay. And your limits will be from 0 to t by 2, and minus into minus, so I'll write this plus. Okay. And this will be integral of this thing will be minus 1 over say okay, sorry, and integral of this thing divided by derivative of this value. Okay. So derivative of this value will be n omega, sorry, n omega. You will need to divide this thing by n omega. Okay. The same way you divide it with the n omega. Okay. And you take the inverse of cos omega t. So you get this, sorry, this is not sine, this is cos. Okay. This is cos. Okay. What was our original formula? This was 2 by t cos n omega t. Okay. So this is cos n omega t. So this will be minus n, and again this will be sine n omega t. Okay. And your limits will be from t by 2 till t. Okay. So this was a little mistake here. Okay. So this is not sine, this is cos. Okay. Now you just apply these limits, and you will get this thing, 2 by t. Instead of t you put t by 2. Okay. So you will get 5 by n omega sine of n omega capital T over 2. Okay. And minus 0, so I'll skip that part. Okay. Then plus uh, and I'll take another bracket, which will be minus 1 over n omega. Okay. First I put this t over here, and then t by 2 over here. Okay. So this will be sine n omega capital T. Okay. And then minus into minus plus 1 by n omega sine of n omega t divided by 2. Okay. So this is your a n. This is your a n. Okay. So this is how you find a n. Now you already find out n, but let's look weird and a little bit lengthy, so we can simplify this. Okay. And you will see we will get interesting results over here. Okay. Now we already know that omega is equal to what? 2 pi f or 2 pi over t. Okay. So just put omega equal to 2 by t over here, and over here. This will shrink this equation. Okay. This will get a little bit simplified. Instead of these 3 terms, you will get 2 terms over here. Okay. So our life will be easy dealing with 2 terms compared to 3 terms. Okay. So if we put omega equal to 2 pi by t in this equation, okay, what we're gonna get is this thing, a n equal to 2 by t 5t over n 2 pi sine of 2 pi sorry n times 2 pi t over 2t, okay, minus t by n 2 pi sine of, remember we are just putting omega equal to 2 pi by t, okay, sine of n 2 pi into t divided by t, okay, and plus t by n 2 pi sine of n 2 pi t divided by 2t, right? That's what we get. Now you can simplify this thing by cancelling t over this and cancelling this 2 over here. Uh, this is okay, this t cancel with this one, this t cancel with this, then the 2 cancel with this thing, right? So what you get in the end is you take this 5 common, okay, no, you don't need to take common values from here, okay, this is multiplied with all these things, okay. So in division you have this 2, you have this 2 and this 2, you cancel it with this one, and in numerator you have t, so you cancel these t values with this t value, right? So what you're gonna get, you get 5 sine, here you only left with n and pi, okay, and in division you have n pi, right, minus, here you get 1 by n pi, okay, and then this will be sine n 2 pi, okay, n 2 pi, and then plus 1 by n pi, okay, and sine of n pi, right, and sine of n pi, okay. So this is what you get in the end. You can see that this and this can be added together, so we can add them together. This becomes 6 sine n pi, okay, divided by n pi, this is n, okay, n pi or n pi, and minus 1 by n pi sine of n 2 pi, okay. So this is your an. You will get an interesting result over here. Now what we need to find out, you know that an could be, n will start from 1 and 1 2 and it will reach till infinity, right? So if you put 1 over here instead of n, this will become sine pi and this becomes sine 2 pi. If you put 2 over here, this becomes sine 2 pi, this becomes sine 4 pi. If you put 3 over here, this becomes 3 and 3 pi, and this becomes 6 pi, and so on, okay. So sine pi is what? 0. Sine 2 pi is what? 0. Sine 2 pi is what? 0. Sine 4 pi is what? 0. Sine 3 pi is what? 0. Sine 6 pi is what? 0, and so on. You put the values up and over here, whatever value you want from 1 to till infinity, any integer value you put over here, you will get n equal to what? 0, okay. So simply we can say that for n equal to 1, a1 will be 0. For n equal to 2, a2 0. For n equal to 3, a3 equal to 0, and so on. So this will always 0, okay. So if I told you that if you know that your function is say odd function, then all these values will be 0. Okay, so if in advance, if we know that our function is odd function, we didn't need, we should not do these calculations. Okay, but we don't know that our function was even or odd, so that's why I told you that you need to first find out what if the function is even or odd. So you see the beauty of those even function and odd function. Okay, so the function was odd function, that's why n is equal to 0. Okay, and we saw that. So next time we are not going to repeat this thing. We'll just first look into our function. If the function is even, okay, then we will straight away say that bn must be equal to 0. If the function is odd, we will say that an must be equal to 0. Okay, so all a values must be equal to 0. Okay, this is the conclusion we derived from this previous equation, from this equation. Okay, from this equation we can derive that if you put 1 over here, we will get a 1 equal to, if you put n equal to 1, so this become a1, this becomes sine pi which equal to 0. Okay, this become sine 2 pi which equal to 0. 0 minus 0 is 0. Okay, so a1 equal to 0, then you put 2 over here, and this become a2 sine 2 pi 0, sine 4 pi 0. Okay, and you put any integers value from 1 to infinity, this will always give you 0 value. Okay, so we draw this conclusion from here. Now what next? Next, what we need to calculate is bn. We have to calculate this value bn. Okay, so for this this is simple. Now you can do this yourself as well, but as promised, I'll do it for you. Okay, so value of bn, we'll write the first the formula, that is bn must be equal to 2 by t integral t to t plus t by 2. Okay, f of t sine n omega t times dt. Okay, so this is our formula for finding bn. Now what was f of t? So f of t was given to us like this one, from 0 to t by 2, its value was 5, so this become 5 sine n omega t times dt, and then plus, okay, from t by 2 till t, this function value is how much? Minus 1. Okay, so this is minus 1 sine n omega t times dt. And what you need to do is just to solve this integral. Again, you will follow the same rules as you did for an. Okay, so you first solve this equation, then you simplify that equation, and in the end you get this thing. Okay, so I'll directly write the result of this integral. Okay, because this will take lots of time to solve this integral. Okay, so I'll write the end result, and I'll give you the solution in notes. Okay, that how you I solve these integrals. Okay, so bn, the final answer after simplification you will get is minus 6 over n pi cos n pi plus 1 by n pi cos n 2 pi. Okay, and plus 5 by n pi. Okay, this is what you get at the end, bn, when you solve this integral and you simplify your equation, you will get this thing. This is a cos n pi, cos n 2 pi, and cos plus 5 by n pi. Okay, so you take n pi common and you solve for different values of bn. Okay, so let's say we need to find out b1, then b2, then b3, b4, and so on. Okay, so let's say we find the value of b1. So for b1 means n equal to 1, right? So b1 will be minus 6 over pi cos of pi, right, plus 1 by pi cos of 2 pi plus 5 by pi, right? You get this value. You know that cos pi is how much? Minus 1. Okay, so this become minus 6 by pi. Okay, then this cos 2 pi is what? 1. So this become 1 by pi, and then plus 5 by pi. You get 0. This is 0. Okay, for n equal to 1. In the same equation, okay, we are taking this equation. Okay, so in this equation, if we put n equal to say n equal to 2, then b2 will be minus 6 by 2 pi. Here we put for n we put 2 now. Okay, this will be cos 2 pi. Okay, here this will be cos plus 1 by n pi. So for n I put 2. Okay, so this will be cos 2 pi 1 by 2 pi cos n is 2, so then this become 4 pi, and then plus 5 by 2 pi, right? Now we just need to simplify this thing. Cos 2 pi is 1. Okay, cos 4 pi is again 1, and then 5 pi 2. Okay, so at the end you will get this thing. This is 1, so this become minus 6 by 2 pi, so minus 3 by pi, right? Then plus 1 by 2 pi, and cos 4 pi is what? 1. Or this is how much? 1, yes. So this become 1 by 2 pi, and plus 5 by 2 pi. This is 2 pi. Okay. So 2 pi, 2 pi, everything is common. So 5 plus 1, 6, minus 3 is what? 3. So this become 3 by 2 pi. Clear? This is b2. The same way, if you put n equal to 3 over here in this equation, you will get b3. So I will write directly b3. So your b3 value will be, I already calculated this value. So b3 will be how much? 12 by 3 pi. Okay, and the same way b4 is calculated. How much? This is 0. Okay, b5 is calculated. This will be 12 over 5 pi. Okay, and so on. You can calculate b6, b7, b8, b9, and so on. Okay, you will find out these values. How I find these values? We just put n different values over here, and we get this. First we put 1, we get b1. Then we put 2, we get b2. Then we put 3, then we get 3, and so on. Okay. Okay, so sorry, so I did a big mistake over here. This was 6 by pi. Okay, and this this will be minus 3 by pi, and this will be 6 by 2 pi. So 6 by 2 pi becomes 3 by pi, and minus 3 by pi, so this will be 0. Okay, okay, this is 0. This is not because I write this 2 pi, this is actually pi. Okay, what I did is I cancel 3 with 2. Okay, 6 with 2, so I get just 3. So minus 3 over pi over here, 1 by 2 pi, and 5 by 2 pi. So we add up, we get 0. Okay, so here we can draw an interesting conclusion from this. You see, that b1 when n equal to say uh, and this is not equal to 0. This can't be equal to 0. Okay, this is plus. This is plus value because cos pi is -1 and minus into minus is plus. Okay, so this is not equal to 0. This is 5 by pi, 5, 6, and 12. This is 12 by pi. Okay, so I'll write this down again once again. Okay, so what I get is b1 is equal to 12 by pi, b2 was 0, b3 was 12 by 3 pi, b4 was again 0. Okay, b5 was 12 by 5 pi. Okay, this was b5. So you can see the pattern that what will be b6? All odd have some value and all even numbers have are 0. So this is equal to 0. And again, with odd you can see the symmetry that this is 12 by pi because this is 1. Okay, when 3, this is 12 by 3 pi. When this is 5, then this is 12 by 5 pi. When this is 7, b7 will be 12 by how much? 7 pi, right? And so on. You can write b8 is equal to 0, and you can write b9 is equal to 12 by 9 pi, and so on. You will get used to it, and you will do this just by looking into it, and you will write the next values yourself. Okay, so but you need to practice. Okay, now that we have find out the values of a naught. Okay, a naught was 2, right? A n all values were zeros, and we find out b n different values. Okay, now we can write our Fourier series simply. That will be our final value. That will be v is equal to a naught plus summation n equal to 1 to infinity a n cos n omega t plus b n sine of n omega t, right? So we find out values of a naught. This is 2, right? And plus you see that in all these values, all values are b, we have 12 by pi common, right? 12 by pi, you can take 12 by pi common here, from 12 by pi common here, from here as well. Okay, and we know that n equal to 0, so this whole term will go to 0. Okay, you will left with only these terms. Okay, so this will be summation. When a n equal to 0, this will be summation n equal to 1 to infinity. You will only left with bn sine n omega t. Okay, this is omega n omega t. Okay, you are left with only this value. Now you put different values of you can evaluate this summation. Okay, so this will be we can write this 2 plus, I told you 12 by pi can be taken common. Okay, into what will be b1 was what, 1, so this is sine sine omega t. Okay, plus 1 by 3 sine of how much, 3 omega t, right? And then sine of, then plus 1 by 5 sine of 5 omega t plus so on till infinity you can go. Okay, you put different values over here and you will get your desired result. So this is our Fourier series. These are our Fourier coefficient. So what we did, we took our example. So we'll go back to our example from where we take our example. Okay, and I'll show you that how can you build your that function from your sine functions. Okay, so this is what we did. that we took this example. This was our example, right? We said that this value is -1 and this is 5. Okay, and this is pure square wave. Okay, and what we did, we write this square wave, this function, in term of summation infinite sum of sine wave. Okay, and how? So it means that if you add these terms infinitely, you will get and you plot them, then you will get this plot. Okay, how? I'll show you. Okay, you can use MATLAB to plot this function by yourself. Okay, so what we do over here, that first this is 2 plus 2. Okay, so whatever your sine value over here is, it will shift 2 times above its plot. Okay, so uh, this is your original function. This is your fundamental frequency. Okay, this is your fundamental component. Okay, what is this component? This is only this component, 12 by pi sine omega t. This is your this component. Okay, now we can add the third harmonic with this one. Okay, so we take just first two terms. This is a DC value. Okay, and this two term, this is first harmonic and this is third harmonic. Okay, what I mean by third harmonic is that look at frequency. This is omega and this is 3 times of omega. Okay, so harmonics are integers, multiple of the fundamental frequency. Okay, so if this is omega, this is 3 omega, this is third harmonic. If this is 5, this is fifth harmonic. If this is 4, then this is fourth harmonic, and so on. So here we just take fundamental and third harmonic value, and this is how your plot look like now. Okay, now if you add say fifth harmonic with this one again, then you will get this value, this function. This is your function. Okay, the same way if you take the 7 harmonic with it, okay, 7, 9 and 11 harmonic with this, then you get this one. Okay, and then you can take 13, 14, 15, 13, 17, 19, 21, 23, 25, 27 and so on. The more the harmonic you add up, you will reach to the exact square wave. You will get the exact square wave over here. Okay, so that's how you can build your own function generator by using Fourier series, that whatever periodic function, periodic waveform you require, okay, you can make that periodic function using Fourier series. Okay, Fourier series will help you a lot. Okay, so that's it for today. What we did in this lecture is that we studied about Fourier series. Okay, and then we learned what is Fourier series. This was the main function. What was these a n, b n, and a naught? This was coefficient, Fourier coefficients, and then how we find these values, a naught, a n, and b n. So I told you the formula for it, that how you find out a naught. This is actually the average value of your function. Okay, how you find an, this an value, this is your function multiplied by cos n omega t. Okay, an integral from t to t plus t by 2. Then how you find bn, this is the same integral, f of t, but sine this term. Okay, then you find this bn values, you find these different bn, an, and on a not value, you put it over here, you get your desired result. Okay, so these are the infinite summation of sine, which Fourier promises us that given any periodic function, okay, you can write it in terms of infinite sine functions. So these are your desired sine functions. Okay, so that's it for today's lecture. There are some problems in your book. Go through it and try to solve them, and then come back if you face any problem. Okay, but go to these say even function and odd function, because that will greatly help you with these values. Okay, if a function is a odd function, then an will be equal to 0 and bn will be not equal to 0. Okay, and if a function is even function, then an will be not equal to 0 and bn will be equal to 0. So you will not need to find out pn, you will not need to find the second integral. This will automatically goes to 0. Okay, for even function this will be equal to 0, for odd function this will be equal to 0. Okay, so that's it for today. We will have a live session this Thursday, that will be 18th of June 2020. Okay, if you have any question, we'll discuss it then, in live session, inshallah. Okay, thank you. Go to a lecture and try to understand the concept. Thank you very much.